Pleasant morning to one and all. I'm Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. Today we are going to discuss about tuning the learning rate in deep learning in neural network. The tuning the learning rate is a critical aspect of training a data learning model effectively. The learning rate determines how quickly the model parameters are updated during the training based on the gradient computed from the loss function. Choosing an optimal learning rate can significantly impact the conversion speed, stability, and the final performance of the neural network. The importance of the learning rate tuning impact on the training dynamic convergence speed. A properly tuned learning rate can lead to faster convergence training process, reducing a number of epoch needed to achieve a satisfactory results. And the stability at a too high learning rate can cause us a learning training process to oscillate or a diversive over a low learning rate can lead to a slow convergence or getting stuck in a lower minimal. The generalization performance, the optimal generalization, a well-tuned learning rate helps a low model generalize better to unseen data, improving their performance on validation and the test set. The strategies for the fine-tuning learn, the manual adjustments where the starts conserving or incremental adjustment. The start conservatively begins with a small learning rate, train the models for a few epochs to observe the initial training dynamic. And the incremental adjustments gradually increase or decrease the learning rate based on the observed training and validation metric. For example, if the loss decreases too slowly, consider increasing learning rate. If it oscillates or increases sharply, decreases the learning rate. The learning rate schedulers stop decay, reducing the training rate by a factor after a fixed number of epoch or even validation losses plateau. Exponential decay. The decay the learning rate exponentially over a time, which can help in fine tune towards the end of training. Cosine and healing gradually increases or decreases a learning rate following a cosine function, which can improve the model conservatively and generalizations. The automated techniques or the basic challenges in setting in deep learning a neural network with an interactions with the batch size, optimizations, algorithm dependency, and computation cost tuning. The learning rate finders using this technique automatically determines an optimal learning rate based on the loss dynamic during a short training runs. Plot the loss against a different training rate and select the points where loss decreases more rapidly. The best practices for the learning rate fine tuning were monitoring a training dynamics, loss and metric. Track the training and validation metric to identify the learning rate impact on a model performance, and the visualizations where it plots learning cure to visualize effect of different learning rates on the model convergence and stabilities. The challenges as considerations for the different methods of tuning learning rates or the model architectures or the manual selections and experimentations with the model architectures and complexities. The optimal learning rate can vary dependently on architecture, datasets, complexity of the task, larger model or a larger complexity during a different learning rates. The training stabilities and the hyperparameter interactions will also be added up with the learning rate schedules with the stop decaying, exponential decaying, performance based, and automated based. Hence, these training stability, finding a right balance between a training speed and stability is very crucial on these methods. And the learning rate is too high can lead to unstable training, while a low training rate may also slow down the convergence, which falls under the learning rate schedules. And the automated methods where the learning rate interact with other hyperparameters like batch size, optimizer size, choice, and regularization technique. Considering these interactions while tuning the learning rates and so on. Um, the gradient, as I state about the gradient based optimizations, where the gradient optimizations Well-tuned the learning rate helps a model generalize better to unseen data, improving their performance in validations and the testing. An adaptive learning rate is also will also be help you for the better understanding of improving the stability, enhancing the generalization performance of the neural network across the various tasks and the data sets. Hence, I conclude this by stating that tuning the learning rate is a crucial step in optimizing the training process of deep learning model. Beyond or deploying the manual adjustment, learning rate scheduler or automated scheduler like LR finders, ensuring that the chosen learning rate align with the specific requirements of your model and the applications. I hope you are clear with this concept. Thank you.